Okay, so going back to the PowerPoint presentation or PDF, uh, this is the content of FAR Part 23, Subpart C, Structure. So maraming subpart yon, pero I mainly focus kung ano yung subject natin, which is aircraft structures. So this is the minimum airworthiness requirements na should be complied by the aircraft manufacturer or kung sino man nagde-develop or nagde-design ng isang aircraft. So, subpart C with structural design envelope, the applicant must determine the structural design envelope. So that is your BN diagram or VG diagram, which describe the range and limits of airplane design and operational parameter which applicant will show compliance with the requirements of this subpart. The applicant must account for all airplane design and operational parameters that affect structural loads, strengths, durability, and aeroelasticity. Okay? So, yung BN diagram na yun, consists the structural design airspeed, landing descent speeds, and other airspeed limitation at which applicant must show compliance to the requirements of this subpart. The structural design airspeed must be efficiently greater than the stalling speed of the airplane to safeguard against loss of control in turbulent air and provide sufficient margin of establishment of practical operational limiting airspeed. Design maneuvering load factors not less than those which service history shows may occur within structural design envelope, and inertial properties including weight, center of gravity, mass moment of inertia accounting for. Each critical weight from the airplane, empty weight to the maximum weight, and the weight and distribution of occupants, payload, and fuel. Characteristic of airplane control system including range, motion, tolerance for control surfaces, high lift devices, or other movable surfaces. Each critical altitude up to maximum altitude should be known to the structural design envelope. So, under that subpart C is structural design loads. Okay, structural design load. The applicant must determine the structural design load, most likely externally and internally applied pressure, forces, moments that may occur in flight, ground, and water operations, ground and water handling, and while the airplane is parked or moored. Determine the loads required by the paragraph A sub 1. So technically, you go back to this graph, to this paragraph. The magnitude and distribution of applicable structural design required by this section must be based on physical principle. Flight conditions, atmospheric gas, magnitude and gradient of this gas are based on measured gas statistics, asymmetric thrust resulting from the failure of power plant unit. And next is groundwater load conditions from taxi, takeoff, landing, handling conditions, and component loading conditions, no? So, yung diniscuss ko kanina sa part 1 or from the part 1 is nandito lang, no, sa lahat sa FAR. So, each engine mount and its supporting structures such that both are designed to withstand load resulting from power plant operation combined with flight gas and maneuvers and non-reciprocating power plant, sudden power plant stoppage. Each flight control and high lift surfaces, their associated system and supporting structure resulting from inertia, mass balance attachment, flight gas and maneuvers, pilot or automated system inputs. System includes condition including jamming and friction. Taxi, takeoff, and landing operation on the applicable surface, including downwind taxi and gas occurring on the applicable surface. Pressure cabin resulting from the pressurization differential or depth pressurization of the cabin from zero up to maximum relief pressure combined with gas and maneuvers. From zero up to maximum relief pressure combined with ground and water loads. If the airplane may land with the cabin pressure and at the maximum relief pressure multiplied by 1.33, omitting all other loads. Okay. Limit and ultimate loads. Applicant must determine the limit loads which are equal to the structural loads design unless otherwise specified elsewhere in this part. And ultimate loads which are equal to the limits load multiplied by factor of safety otherwise specified elsewhere in this part. So I think FAR 23 when it comes to bolt and nuts, they have a 1.2 to 1.25 specified factor of safety. Next is aerodynamic characteristics, no? So simply the external loads is coming from your aerodynamics forces, no? So overall aerodynamic characteristic of the aircraft are important to the determination of structural loads. Some of the necessary information that must be determined by analysis and wind tunnel tests are basic aircraft characteristics when it comes to stability, pressure distribution over the wing, empennage, and fuselage, control surface hinge moments, and pressure distribution over high lift devices such as flaps and slots. Okay, load analysis. Design loads are determined for the various structural components using computers. Some of the analysis required are, okay, so naulit lang. Maneuver load analysis, gas load analysis, from static approach to dynamic approach, landing loads analysis including both and rigid airframe, and dynamic analysis, ground handling loads including both rigid and elastic aircraft characteristic, control surface, reversal characteristics and load distribution, dynamic analysis for control surface oscillatory condition due to blackbacks, autopilot, yaw damper failure, flutter analysis and tests including both wind tunnel and flight testing to verify the adequacy of damping characteristics of the aircraft throughout the speed range. Flight loads, no? Flight loads is from the BN diagram, as you can see. So aircraft operating variables. Rating variables for which critical values must be determined in showing compliance with the flight load requirements are, okay, one is flight altitude, operating weight, and the center of gravity travel. So unang-una sa flight loads is the maneuver loads. Okay? In terms of symmetrical flight, no, at least steady level flight, BN diagram is used. No, B represent aircraft speed and represent load factors, and to represent the maneuver load requirements for an aircraft because of the effect of compressibility on the wing, wing lift and effects of varying air density to aircraft speed capability. BN diagrams have different shapes at different altitudes, and all critical combinations of altitude, weight, and travel position must be investigated. Within the limits of the diagram, the aircraft must be checked for both balance and pitching maneuver conditions, In a balanced condition, an aircraft is assumed to be equilibrium with zero pitching acceleration. This can be achieved in a steady state pull up or turn. All critical points around the periphery of the diagram must be checked for this condition. So as you can see, flap up case, this one, when it comes to negative limit load factor, and this one is the flaps up and positive limit load factor. For airworthy transport category designed to a minimum positive limit load factor of 2.5 up to negative 1.0. Okay, so yan lang yung range ng transport category, part 25. Limit load is positive 2.5, negative 1.0. So yung limit load na yan, yung values niyan, no, pwede kong ibigay sa inyo or design. No, the design instructor will be the one no to discuss the limit load. Again, the flap down case, as you can see, different, no? Nakita nyo yung mga broken lines is different. And flap down maneuver requirements are derived in the same ways as those for flap up except affected by the following differences. Maximum limit load factor of 2.0 is required, no, for the positive only. And BN diagram is limited by speed VF, which is equal to the stall speed multiplied by 1.6 or 1.8 depending the aircraft weight condition and flap setting. So BF is, if hindi ako nagkakamali, is the speed of the aircraft flying flaps down or retracted. Okay, rolling case, no? As you can see, pwede naman ninyong basahin yan all throughout, no? During your free time. So BA is the speed, maneuvering speed. BC is cruising speed, and this is, I think, B dito. Okay. Yawing case, this is the BN diagram for gas condition. So formula for the gas condition is to be given sa succeeding or sa next video. KBV is the gas speed, BC, this one. No, the gas speed, BC cruising, BD is diving speed. I hope dumating yung point no ng technical reports na makagawa tayo ng BN diagram. So yan, nagbibigay lang siya. Technically, yung niligay ko dito is nagbibigay siya ng condition dun sa sa inyong BN diagram, no? Ano yung mga requirements, ano yung kailangan sundin when it comes to procedure sa analysis. No, up to this one. No, simply nagbibigay lang siya ng condition on how uh, to do it, no, how to do the BN diagram when it comes to flap down case, rolling case, yawing case. Okay, and very important na alam ninyo. Okay, so mga natitira dito is about computation na, more of sample problems ng aircraft loads. Okay, so a sample, no, in figure below, figure illustrates an airplane landing on aircraft, Navy aircraft carrier and being arrested by a cable pull T on the airplane arresting hood. So the airplane weight is 12,000 pounds, so that is your weight. And then the airplane is given a constant acceleration of 3.5 g, which is equal daw sa 112.7 feet per second squared. Find the hook pull T, the required, and the wheel reaction R, and the airplane, if the landing velocity is 60 miles per hour. 60 miles per hour. What is the stopping distance? Okay, so that is CG. What is the airplane and the airplane between the line of action hook pull T and the airplane CG? So this one, itong D na to. Itong distance daw na to. Okay, we need to write our simple free body diagram. Okay? So again, the Cartesian. Meron tayo, dahil sinabi at landing, no, ang importante masulat natin ang MA. MA sub X. So papunta going to the left. This is say direction. Say this is X. Okay? Next is the weight, which is 12,000 pounds. And that is at acting at your CG. Okay? Next is R. No, R is acting to this one. The reaction at will. Merong distance na 24" no, from the CG. And then, yeah, and the D. So we assume no yung arresting hook pull T or yung cable pull is acting to this one. No? If this is the line of action ng CG, so maybe the pull T is, yan. This is T and this is the unknown D, small d. Okay? So ayan. So on contact of the airplane, no, the arresting cable, the airplane is decelerated to the right, no, relative, no. So ibig sabihin landing, as you can see sa picture, deceleration yung nangyayari sa kanya. The motion is horizontally, the inertia force is shown dun sa ating free body diagram. So kung kukumputin natin yan, that is what? MA X is equal to W over G. And AX, no, as given is what? 3.5 G. So 3.5 G. No? So bakit W over G? So W is equal to mg. So in-insert lang natin yung value ng m when it comes to W over G. So MAX is equal to, therefore cancel out 12,000 pounds 3.5. So that is equal to what? No, from your calculator, that is 4,200 pounds. Okay, so that is your inertia force. And inertia force acts opposite to the direction of deceleration, no, ng acting acceleration. Okay, so as you can see, no, MA is inarrowed nung figure. So susundin natin itong figure na to. So next is we get no the value of P in terms of summation forces Y. In terms of summation forces Y or summation forces X. So we have value of MAX. Therefore, pwede tayo magkaroon ng value ng T at summation forces X. Summation forces X is equal to 0 going to the right is positive. So itong angle daw na to is 10 degrees. Okay? So that is 10 degrees. Summation forces X, MA, X is negative. So negative for 2,000 pounds. Okay? And then positive cosine 10 degrees times T is equal to 0. Okay? And T is equal to 42,000 pounds cosine 10. So T is equal to 42,647.9177 pounds. Okay? So that is your tension. Okay? Next is using summation forces Z is equal to 0. Going up is positive. Meron tayong R1 or R, simply R, positive R minus weight, 12,000 pounds. And then, um, negative sine 10 times T. Okay? So yung T natin, tension is store A. And then equal to 0. Therefore, R is equal to 12,000 pounds plus 7,405.73319 pounds. And R is equal to 19. Okay? So that is 19,405. 19,405.73319 pounds. Okay? Then store B natin, baka kailanganin pa natin. Ship store B. Next is determine, no? Find the distance D between the line of action of the hook pull T and the airplane CG. So ngayon, no, after summation of X, summation forces Z, you need, next is summation moment naman, no? So let's try dito na lang. Summation moment A is equal to 0, clockwise positive. Okay? So wala palang A dyan. We use summation moment CG is equal to 0, clockwise positive. So pag nag-moment ka sa CG, mawawala yung MEX and the 12,000. Meron lang tayong value of T and the value of R. So that is D times T, correct? And then negative kasi opposite to the direction of movement. And then plus R times 24 inch is equal to 0. Okay? And then D is equal to R 24 inch over T. And D is equal to store B pounds 24 inch over store A pounds. D is equal to cancel out ang pounds. So from your calculator, store B times 24 over store A. And will result to 10.9205 to 371 inch. Okay. Next is what is the stopping distance when it comes to velocity of 60 miles per hour? Okay. Yung 60 miles per hour, we will convert it first to feet per second. 60 mile per hour. That is 88, no? 88 feet per second. Okay? So, 1 mile is 5 to 80 feet times 1 hour is 3,600 seconds. Okay, so from your calculator, that's equal to 60 times 5 to 80 over 36. That is exactly 88 feet per second. And from your equation ng physics, no? From your physics and dynamics, we have final velocity squared minus initial velocity squared is equal to 2as. And then, final velocity is 0. Bakit? Kasi landing. Okay, initial velocity is 88 feet per second squared. 2 times the acceleration given is negative, no? That is 112.7. Negative 112.7 feet per second squared because of deceleration times S. So S is equal to negative 2 times 112.7 feet per second squared over negative, baligtad. So that is negative 88 squared feet squared second squared over negative 2, 112.7 feet per second squared. S is equal to cancel out, cancel lang second squared. So distance must be equal to 34. 34.3566992 feet. Okay? So okay, so I hope walang mali dun sa um, mga sign convention. Kasi dito, no, ngayon ko lang nakita. Ito, this is negative. Okay? Okay, next is this one. Airplane daw is equipped with float. So, ibig sabihin that is amphibian airplane or water airplane catapulted into the air from a Navy cruiser as illustrated in figure 4.16. The catapulting force P gives the airplane a constant acceleration of 3G. Okay? Na equal yung 3G sa 96.6 feet per second squared. The gross weight of an airplane is 9,000 pounds and the catapult track is 35 feet long. Find the catapulting force P and the reaction R1 and R2 from the catapult car. The engine thrust is 900 pounds. What is the airplane velocity at end of track run? Okay, so we write first the given. Okay, so meron tayong given. Given, merong acceleration 3G equal to 96.6 feet per second squared. Okay, so kung ano yung binibigyan ng problem na conversion, yun susundin natin. Next. Okay, using ko lang 96.6 feet per second squared. Next is gross weight of an airplane, weight of 9,000 pounds. And the catapult track, no, distance is 35 feet long. Find the catapulting force P, that is the required P, reaction R1 and R2, and what is the airplane velocity? Okay, so that is your final velocity. So dahil di naman siya paland, so ibig sabihin, initial velocity is equal to 0. Okay? So ganyan magsulat ng mga given. Next is we write no yung mas simpler version of the figure. So start ka with the x and y axis mo or x and z axis. So paano ko nasabing x and z? Ayan, sa figure sinasabi. So meron sa gitna na CG. Okay? From that CG, acting ang yung weight, 9,000 pounds. Next, no? Dahil pa makikita sa figure, no, yung inertia force is going to like MAX. Next, yung CG and thrust line is merong 5 inches. Ibig sabihin, kung magdodrawing ako ng thrust line, nandito ang thrust, which is 900 pounds. And that is 5 inch, no, above sa CG. Next is your load E, no, yung bumato sa kanya. So nilagay lang natin sa ground, 78, no, 78 inches from the CG. So from the CG, ito yung load P mo. Ito yung unknown. Okay, P. And that is, kung meron kang 5 sa taas, this one is 78 inches. Okay. Next is R1. No? So you can see R1 is 55 inches from the CG. So this is your R1 and this is 55 inches from the CG. And ano pa? R2. R2 is what? 85 inches. 85 inches from the R1. So ito yung R1. This is your R2. So kung 85 yan minus 55, that is only, okay, para sure, 30. 30 inch. Okay? So ang distance ng R1 to R2 is 85 inch. Next, wala na. Okay? So MAX. Okay. Next is, syempre, we start no to determine what is the horizontal inertia force, no? Inertia force acting toward the air tail or sa plane nung isang eroplano. Okay. So from the given MAX is equal to 0. No pala, sorry, is equal to 0 is WGA sub X. And MEX is equal to 9,000 pounds over G times 3.0 g ang given no, na acceleration. Okay. So we cancel out and max is equal to 27,000 pounds. Okay. From your static summation forces X, okay, summation forces X is equal to 0, going right is positive. So mga X component lang natin, we have 900 pounds negative. The thrust line, 900 pounds. Next is the positive MAX, 27,000 pounds. Next is, yeah. Next is P. Okay, load P na. That is negative. P is equal to 0. Okay? So, transpose sa kabila, positive P is equal to 26,100 pounds. So, that is your force P. Next is to find R2. So, dahil unknown is dalawa, we cannot jump to the conclusion na summation forces Z. So, we need to summation moment muna. To find R2, no, we take the points or we can moments R1 or R2 para mawala yung isang value. So, we try to moment at R1. Okay? So, summation moment R1 is equal to 0, clockwise positive. So, that is negative, okay? Is negative 900 pounds times 83. No, 78 plus 5, that is 83 inches. Next is 9,055. So positive 9,000 pounds, 55 inch. Next is the MAX, positive 27,000 pounds times 78. Tama? Okay, 78. And the next is R1 to R2. So that is 85. So negative R1, R2, sorry, R2, 85 inch. Okay? Ano pa? Ayan. So tingnan nyo mabuti kung meron pa. Minus 85 R2. So tingnan natin dito sa original. So as you can see, yung P is acting kung saan yung point ng moment natin. So therefore, there are no or there is no perpendicular forces kaya walang P dyan. So goods na tayo, makukuha natin yung R2 is equal to 0. So isam lang natin to lahat. That is negative 900 times 83 plus 9,000 times 55 plus 27,000 times 70. And that is 252 6,300 pounds inch minus R2 85 inch is equal to 0. And R2 is equal to, no, divide 85. Okay, so 29,721.17647 pounds store A. Okay, next is to get the R1. Okay, how to get that? Summation forces X. Summation forces Z, sorry, is equal to 0. Going up is positive. Meron tayong R1 plus R2 and then the minus 9,000 is equal to 0. Okay? R1 plus store A pounds minus 9,000 pounds is equal to 0. And R1 is equal to 2721. 2721.17647 pounds negative. So dapat R1 is acting downward. R1 is 2721.17647 pounds acting down. Okay, right? Okay. Next is this one, no? No, hindi pa pala tayo tapos dito kasi ang may nahanap pa, which is velocity at the end of track run. Okay? So, I think kasya pa dito yung velocity sa upper right. Move na lang natin to. Okay? So, velocity. To find the velocity, we need the equation from your dynamics. Final velocity, velocity squared, initial velocity squared is equal to 2as. Final velocity is unknown. No, yan yung hinahanap natin. Minus 0 kasi from the static niya, no? Kasi taking off. 2 times 96.6 feet per second squared times the 35 feet landing run. So BF squared is equal to 2 times 96.6 times 35. 6762 feet squared, second squared, squaring both sides. Oh, so that will be cancel out, cancel, cancel, cancel. Final velocity is 82.231823.38087 feet per second. Okay, so that is, that should be the aircraft final velocity. Okay, question, if you have questions during our synchronous meeting, dun tayo pwede magtanong. Okay, next. Ayan, as you can see that one. Okay, so next is when landing on a carrier, a 10,000 pounds airplane is given a deceleration of 3 Gs by means of cable engaged by an arresting hook as shown in figure. Find the tension in the cable. Okay, wheel reaction R and the distance E from the center of gravity to the line of action of the cable, and find the tension in the fuselage of vertical section AA and BB if the portion of the airplane forward section AA weighs 3,000 pounds and the portion aft section BB weighs 1,000 pounds. Find the landing run, and then if the speed is 80 feet per second. So, same, hindi naman same, no? Somehow similar yung yung problem na to dun sa ating na-solve kanina. Okay? So first, we write the given. Okay, dito na lang, no? So ang given, meron kang 3G lang. That is your A sub X, which is 96.6 feet per second squared. Weight, 10,000 pounds. And then the other is from the figure. Okay? 20 inches. Um, assuming malabo, this is 10, no? 10 degrees. So 10 degrees. And then that's it. Okay? So again, no, we simplify the figure. So again, meron tayong weight acting on the CG. So that is your weight, which is 10,000 pounds, no? Sabi. Next is MA. And as you can see, going to the left direction ng ating MA as per figure. Next is the R. Okay? So, nandito yung reaction at wheel. And then the E. So, kanina, tulad kanina, hinahanap yung distance. So, this one, syempre, yung cable T is not on the CG. So, assuming, ayan, dito siya. And this one is the line of action of your CG. So, this is T, wherein that is 10, sorry, that is 10 degrees. Nahanap is the distance. Okay? So, assuming letter E. Okay? So, wala na ba? Okay, so I think wala na. The rest is will be used for the letter B. So we get first the tension with reaction and the distance E. So same process lang kanina. We get first the MA. Okay, the MAX. So MAX is equal to WG times the A. And W is 10,000 pounds over G. Ang given is 3G. Okay? So MAX, cancel out. MAX is equal to 30,000 pounds. Next is summation forces. X is equal to 0. Going right is positive. So from the equation of free body diagram, we only have negative MAX, 30,000 pounds, plus cosine 10 degrees times T. is equal to 0. So T is equal to 30,000 pounds over cosine 10. E is equal to 30,462.79836 pounds store A. A ship store A. Next is no, pwede nating summation forces Z. Kung nasanay na kayo, summation forces say going up is positive. We have R, positive R, and then negative weight, 10,000 pounds. And then negative sine 10 times T is equal to 0. Okay? So we have value of E. R is equal to 10,000 pounds minus the value of T times sine 10. So positive pala. Positive 5289.809421 pounds, and R is equal to 15,289.809421 pounds store B. Store. So that is the value of your R. Next is to get the value of the distance ng T to the CG. So simply, same lang, summation moment. CG is equal to 0, clockwise positive. We get rid to the values of MAX and 10,000. We only have the T. So that is negative E times the value of T plus R, no, that is 20, okay, 20 inch from the CG to positive 20 inch times R is equal to 0. Okay, E, positive E is equal to 20 inch times R, store B values pounds over A pounds, no, the value store at A. So E, or distance from the center of gravity to the line of action ng cable T is equal to 10.03834857 inch. Okay. Next is what? Oh, merong mga conditions na given. So find the tension in the fuselage at vertical section AA, which is this one, no? Taking this one, and the BB if the portion of the bring forward section AA weighs. Okay, so this one. Okay, so portion AA daw weighs what? 3,000 pounds. Portion BB weighs 1,000 pounds. So in order to solve that, no, start ka pa rin, no, to draw your simple diagram. Okay? So first is consider the kahit ano, no, pwedeng mauna yung aft section, pwedeng mauna yung forward section. Okay, so consider natin yung aft section. From the from the aft section of the fuselage, no, yung P-body diagram mo should be this one. Okay? So again, meron ka ditong CG kung saan dito nag-a-act yung 1,000 pounds mo. Okay? And then, um, MA na 30,000 no, is given. And then, due to inertia force, no, MA X is equal to W over G times the 3.0 G. Correct? So, MAX is equal to 3,000 pounds. So, saan nag-a-act yung MAX mo? No, same direction. So, this is your MAX. Okay? And then, meron kang cable T. Ayan. So, meron kang cable T dyan. So, yung cable T mo is what? Merong portion na ang value ng T natin is 30,462. So, kailangan mong kunin when it comes sa value ng horizontal and value ng vertical T mo. So, this is your T sub X and this is your T sub Y. Okay? To get the value nung ating T sub nung ating T sub X, no, paano natin kukunin? Simply, no, this is your 10 degrees. Correct? So T sub X is equal to okay, cosine. Okay, sorry. So cosine theta is equal to T sub X over T. Therefore, T sub X is equal to cosine 10 times T. T sub X is equal to cosine, okay, cosine 10 times alpha A. So that is 30,000. Okay, so that T sub X is 30,000 pounds. When it comes to T sub Y, so that is sine theta is equal to T sub Y times T. T sub Y is sine 10 times the T. T sub Y is equal to 5289.809421 pounds store C. Okay? Dahil hinati natin, no, magkakaroon ng um, tension on section BB kung saan nandito. Okay, so ito yung BB, kailangan magkaroon ng equilibrium. So ano yung equilibrium na yun? That is your tension acting on the section BB. Okay? So dito on top of this MAX is merong T sub 1. No, yung T sub 1 na yan identifies na siya yung tension. And there is no vertical acceleration, there is no vertical inertia forces. However, section BV has a shear force. No, kasi nag-cut tayo. Ibig sabihin, no, merong axial load dito, axial force. Dahil nag-cut tayo, meron ditong shear force. Okay? So yung shear force na yun is equal to the sum of the weight and vertical component of the cable force. So this is B sub 1. Okay? Simply, to get T sub 1, summation forces X is equal to 0. Going right is positive, negative T sub 1 minus 3,000 pounds plus 30,000 pounds is equal to 0, and T sub 1 is equal to 27,000 pounds. Okay? So, ang hinahanap kasi ng problem is tension in the fuselage and the vertical sections. So, vertical sections identify the shear force, and tension on section BV is 27,000 pounds. Summation forces C is equal to 0, going out is positive. Meron tayong B sub 1 minus 1,000 pounds and minus store C pounds. B sub 1 is equal to 6289.809421 pounds. Okay, that is for section BB. Okay. Next is for section A. No, dun sa forward section naman. So, we need to draw again the free body diagram. So, again, meron kang Cartesian. Yung Cartesian plane mo na yan is mayroong CG. Yung CG na yan, nag-aak yung weight ng binigay is 3,000 pounds. Okay? Next is your MA. Okay? MAX. Next is your tension, no? T sub 2, and then your vertical section. So, technically, madali lang, no? Kailangan lang natin kunin yung MAX. MAX is equal to W over G, T, G. Cancel, cancel. MAX is 9,000 pounds. Okay? So, paano naging 9,000? Simply, yung weight na ginamit is 3,000 pounds. Summation forces X is equal to 0. Going right is positive. E sub 2 is equal to 9,000 pounds. That is tension acting on the section AA. And summation forces C is equal to 0. Going up is positive. B sub 2 is equal to 3,000 pounds. Okay? Okay? So I hope walang question dito. Next is find the landing run in the landing speed, no, from your elementary dynamics, no, from your statics of dynamics of rigid bodies. Meron tayong formula. Final velocity squared minus initial velocity squared is equal to 2 AS. And dahil landing, no, landing configuration ng ating aircraft, when landing on a carrier, so Final velocity is 0. Initial is 80, no, as given, that is 80 feet per second. 80 feet per second squared is equal to 2. Ang ginawang conversion is negative 96.6 feet per second squared S. So, alam niyo na kung paano naging negative, no, kasi deceleration and landing. So, that is 80 squared over 2 times 96.6. So, we have 33.126294 feet landing run. Okay. Okay, so I hope no gets you na through three problem solving yung ating parameter. Ito, this one is for practice. No, pero very basic na lang din. Same process, ulit-ulit lang. Thank you, and I hope now during synchronous you have questions.